the Thomas Edison one that first, and after that the Tesla one, all right, with AC. So this is power supply, and these are the transformer. Do I need it for Thomas Edison? No, I don't need it. This is for Tesla only. It was not invented by Tesla, but invented by Faraday actually. But Tesla is the one smart enough to use this idea for power transmission. Anyway, we don't use this. We use this one. It's a power supply, and I've got a light bulb here. A light bulb here. This is what? I can turn it.
Transformer.
Not transformer. This is just a resistor, which I can change the value. Variable resistor. The one you use is called rheostat. Remember the long, you can slide that thing. This is basically the same, the more compact one. The one you use is more for educational purpose. This one is still for educational purpose, but it's more compact. So realistically, this is just more convenient. But inside, you can imagine that there are so many coils, and I just go for different length of the wire, so change the resistance. I want to ask you, this is of course not the actual power station and transmission, but what is the purpose of these two variable resistors, do you think? Kind of control the current. Maybe I'll show you later on, you'll see why. What is this for then? This is the analogy for power station, very good, which give out the electricity. Okay, so what I want to do is, these two, I'll take this as the long cable. And for long cable, one thing that you cannot avoid is what? Their resistance must be very high, because why? Because they are long, right? That's what we learned from the previous chapter. So right here, what I want to do is I would want to plug in the positive and negative, which means a DC. And I want to compare the light bulb at the beginning, where it's just output from the power source, and after you transmit for a long distance over here. So of course, the one that come out from the power station, we can say as very bright. So this is a circuit, come out here, very simple. At the same time, just want to be fair, I will want to use a parallel circuit. Parallel circuit, so that the voltage on both sides is the same. Alright, so I'll come here, positive, come over here, go to this cable, and this in series, like the one we just did, go into this light bulb, and again, come back here. This light bulb, this is like where? This light bulb actually represent where? The actual building, that wherever, like school or your home, the light bulb that you are using. Okay? After that, we'll build the network back to the power supply. Of course, to negative. Okay? Are you okay with this now? This is one loop. Through the cable, your home, and back to power station. This is just a power station itself. Now, I will switch it on. You can compare that in 1, 2, 3. 1 volt, 2 volt, and 3 volt. This is on. This is not on. You may doubt me. I hope you doubt me as well. Hey, maybe it's just some connection issue, right? And now I try to turn this. It's brighter. I can change the resistance here, so it's brighter and not as bright. By the way, this is also how, if you, at home you have this kind of button, they just use a variable resistor install. It's very simple. So let's say I set this cable to be high resistance enough so that you barely see it. Maybe a little bit more higher. Can you still see it?
Yes.
Yeah, but very, very dim, right? So most of the energy are lost where?
In the cable.
In the cable, in these two places. So you can see this is the original output, suppose how it should be. And then so much energy are wasted here. And you only got that tiny little dim light here. That's the Edison's model. Are you okay with this? Now, what I want to do is, I may use a multimeter. Actually, it's a voltmeter. In certain way, if I switch it to, say, here. If I try to measure, I hope you can see it.
What's the difference?
If I try to measure these 2 points,
What's the difference between the two?
these 2 points, let's say here and here, you find how much? About negative 2.96, right? So that means the voltage here is about 3, and that's normal, because these cables take a little bit, and most of them go into this light bulb. Makes sense?
But why?
What if I plug into this side? Much less. Which is about, forget about the negative, because I can switch this to get rid of negative. 0.7 only. So that's also explain why it's so dim. And most of them go into here.
Yeah, but of course demonstrating that is.
Now I'm going to change it to the Tesla, that one. And remember, we have to use AC. We'll discuss why AC later on, but trust me first, AC.
Why do you need 2 light bulbs to test?
Because I want to show you the comparison, how it should be.
Okay.
And after that, how much it dropped.
Okay.
Of course, I can only show you that one, but it's hard to compare without anything, right? So now all I do is I put into the yellow port here. Maybe help me to split the video.